Why is buckling interaction key in structural design? Imagine a tall building swaying slightly in the wind, or a bridge holding heavy traffic without a hitch. These structures stay safe because engineers understand how different failure modes work together. One of the most important concepts they consider is buckling interaction. When a structural element like a column or a beam is compressed, it can suddenly bend or twist. This is buckling, and it can happen at loads much lower than the material's breaking point. If not properly managed, buckling can cause sudden and catastrophic failure. Now, buckling doesn't just happen in isolation. Different types of buckling can influence each other. For example, local buckling occurs when small parts of a cross-section, like a flange or web, deform first. This weakens the entire member, making it more prone to global buckling, which involves the entire structure bending or twisting. When these modes interact, they can lower the load the structure can carry before collapsing. Understanding how these failure modes combine is essential because ignoring their interaction can be dangerous. Structures might seem stable under static load checks but can suddenly fail when buckling modes activate together. That is why design codes include equations and factors to account for these combined effects. Engineers use these tools to predict the real critical load a structure can handle, considering how different buckling modes influence each other. To prevent problems, engineers often increase the stiffness of members by choosing stronger materials or larger cross-sections. They also add supports or braces to reduce the effective length of a member, raising its buckling load. Careful attention is paid to slenderness ratios, which compare length to cross-sectional dimensions. Higher ratios mean more risk of buckling. Using specific formulas and interaction curves helps predict when buckling might occur, considering multiple modes at once. In some cases, advanced techniques like active control systems or composite materials are used to boost buckling resistance. These strategies help ensure that structures can carry their intended loads safely without sudden failure. Recognizing how different buckling modes interact is a key part of designing safe, reliable structures. It helps prevent unexpected collapses and keeps everything standing tall, even under challenging conditions.